Hey everybody, this is Unit 3 Video 5 and we're going to be doing some applications of right triangles all involving bearing. We're going to be combining the ideas of solving for missing sides and missing angles of right triangles along with the bearing methods from the previous video. So let's go ahead and get started with some word problems. The first example, two lighthouses are located on a north-south shoreline. The watchman from the northern lighthouse spots a ship at a bearing of 154 degrees, while the watchman from the southern lighthouse sees the ship at a bearing of 64 degrees. If the lighthouses are 4.5 miles apart, how far is a ship from each of the lighthouses? So let's go ahead and draw a picture. First thing we're going to do is draw that north-south shoreline, and we're going to put the two lighthouses on there. I'm going to call the first one N for north and the southern lighthouse S for south. And now we'll go ahead and input on our bearings. The first lighthouse from the north sees the ship at a bearing of 154. So I'm going to go past 90 and over to 154. This is the line of sight that northern watchman has. I'm not exactly sure how long it is because I have to make a combination of that with my southern one to see where they intersect. So the southern one has a bearing of 64 degrees. And this is that line of sight, leaving the boat, or the ship, B, to be out here in the water at the intersection of their two line of sights. I'm going to go ahead and use another color and add on all the other information that we need. We know that they're 4.5 miles apart. We also know that this is a 154 degree bearing. If I take the supplementary angle to 154, that is 180 minus 154, I get 26 degrees. Since this one I know is 64 degrees, let's go ahead and check. 26 plus 64 is 90, which leaves this other angle over here located at the boat to be 90 degrees. This leaves us a right triangle that we're able to use to solve. I'm going to go ahead and remove this triangle from all of the busy information, making this B, S, and N, 4.5, 26 degrees, and 64 degrees. What I'm looking for is the distance between the northern lighthouse and the boat and the distance between the southern lighthouse and the boat. I'm going to start by finding the x value. I'm going to use the cosine of 26 degrees to equal x over 4.5. I could use the sine of 464 degrees to find that as well. So there's more than one way to do this. I'm just proposing this way. So 4.5 times the cosine of 26 leaves me with 4.04 miles. Let's go ahead and do the other one. Here I'm going to use the sine of 26 degrees to equal y over 4.5. Again, I could use the cosine of 64. I could also use the Pythagorean theorem, since after finding 4.04 miles, I actually know two sides, so I could solve for the third using a Pythagorean theorem. So 4.5 times the sine of 26 leaves me with 1.97 miles. I need to write this in a complete sentence so that I know what I'm looking for. So the distance to the boat, or the ship, from the northern lighthouse is 4.04 miles, and from the southern lighthouse is 1.97 miles. To just write 4.04 miles and 4.97 miles is not enough information because I don't know, without looking at the picture, exactly what the answer is. So the idea would be to not just provide this, but to actually provide a complete sentence that answers the question. Let's go ahead and try another one. Here's our second example. A truck needs to make a delivery to a warehouse located 265 miles away on a bearing of 220 degrees. Once he completes his delivery, the driver will travel on a bearing of 130 degrees for 310 miles to pick up the next load. How far will the truck be from its original location? So here I have a combination of bearings. Because it's one truck traveling and making a turn, that makes it a combination of bearings. So I'm going to start with my north-south line. And I know that the truck's first, oops, I'm going to move that over a little bit on my paper or my screen. And I know that the truck is going to be traveling, so this is where the truck starts. And he's traveling on a bearing of 220. So that's past 180 degrees and a little bit more. So this is the path on which the truck is going to be traveling for 265 miles. The truck is going to reach its warehouse location, and then it's going to make a second route, and that needs another north-south line. So from here, the new bearing is going to go 130 degrees. So that's past 90, and travel over here for 310 miles until it gets to the pickup. The question is, how far is this truck from the original location? So based on my picture, I have to determine where my right angle is, and it's best not to guess, it's best to prove it. So I'm going to start up at the original bearing from the starting place, and which was 220 degrees. Well, if this is 180 degrees, then this angle that I'm highlighting here in blue is how much past 180 degrees? And the answer is 40. Well, based on the fact that my north-south lines are parallel, and this would be like a transversal, I have alternate interior angles, leading this angle up here to be 40 degrees as well. If that's 40 degrees, and this entire bearing here was 130 degrees, I can subtract the 40 to find that my right angle is in fact located right here in the corner when it makes the turn from its warehouse to head towards its second location. So I'm going to remove this picture from all of the information on that side and just draw a basic right triangle. 265 degrees for its first, that this is 310 miles, and then I'm looking for my hypotenuse. I don't actually know the angle. You might think it's 40, but 40 actually goes with the north-south line and not with the actual triangle that we're using. I also don't know this angle down here because I don't know exactly the bearing that falls between, the angle that falls between that last turn. So I'm left with using the Pythagorean theorem. The important part of us using this is using our bearing is we had to decide where our 90-degree angle was. We found it to be between the 265 and the 310. So my Pythagorean theorem would be 265 squared plus 310 squared to equal x squared. So let's go ahead and find out how far these two he is from his original location. I find it to be 407.8 miles. And that would be our final answer. All right, great job.